Hello and welcome, guys. It's Derek Tafumo again. I just want to look at some chemistry questions here, some calculations, a few explanations. This particular one, question one, has to do with finding the relative atomic mass. So I'm just going to highlight a few things that we need in order to make the calculation. So bromine consists of a mixture of two isotopes, bromine 79 60% and bromine 81 with 40%. The question is to calculate the relative atomic mass of bromine. Show your calculations and give your answer to two decimal places. Okay, so first of all we have, this is question one. And that's part A. We have bromine 79 and bromine 81. The abundance for 79 is 60% and for 81 is 40%. So to calculate the relative atomic mass, you're going to do the 79, the mass number for bromine 79 times the abundance, 60%, plus the 81 times the abundance of 40%, and then you're going to divide both items over 100%. So let's get the calculator out. Put the calculator out. I'll put the calculator over here, and then we're gonna do 79 times 60 plus 81 times 40 and divide that by 100. Okay, so the answer is 79.8, but the question says to express the answer to two decimal points. So to do that, we write a 0 here, because two decimal points means two places after the decimal. The decimal is here, so you need 1, 2 places, which makes the answer 79.80. So that's the relative atomic mass for bromine, for them two, with these percentages. So that was part A. Now let's look at part B. So part B says, complete the table below to show the atomic mass, atomic structure of the bromine isotopes. So I'm just going to draw over this table, and then I'll copy the table. Draw over it, because I'm just going to copy it. So 79 Br, 81 Br, here we have protons, neutrons, and electrons. Okay, and let me cut this. Cut it from there, and I'm gonna paste it here. Paste that. Move it around. Make it bigger. Okay. That's sorted. I'm gonna use a different color pen. But before we do that, we need to find the atomic mass for bromine. and the atomic mass for bromine is 35. So atomic number, not the atomic mass, but the atomic number is for bromine. Don't need this for now. Atomic mass for bromine is 35. Okay, that means there are 35 protons. And it's the same number for both. And it's going to be the same number for the electrons, because in a neutral atom, the number of electrons is equal to the number of protons. So in a neutral atom, the number of protons is equal to the number of electrons. Okay, so to calculate the number of neutrons, because we know that in an atom, inside the proton, inside the nucleus, we have protons and neutrons. So P is protons, and N is the neutrons. Okay, so here, inside the nucleus, we have protons and neutrons. So the total number of protons and neutrons is going to be the mass number. So P plus N equals mass number, which in this case is 81 and 79. So this 79 and this 81 will make up the mass number. So to find the number of protons, would say mass number, or the number of, we're looking for the number of neutrons. So neutrons equals mass number minus the protons, which means it's 79 minus 35 and 81 minus 35. That will give you 46. That will give you 44. So for the 79 it's 44, and for this one it's 46. Okay, so that is the answer to that table, and that gives you 3 marks. You already got 4 marks for that, and now you need to do the full electronic configuration of bromine, and the mass number for bromine is 35. So that is part C. So we need to do for 35 electrons. So we always start with 1s2, 2s2, 2p6, 3s2, 3p6, and from 3p6 we go to 3d10. Then we're gonna have 4s2. So let's just keep stock of how many we've got so far. We've got 2, 4, 10, 12, 18, 28, 30. So I'm just left with 5. So it's going to be 4p5. So this is the electronic configuration of bromine. Okay, I hope this one helps. I'll be back again with question 2, which has to do with calculating the relative atomic mass again, and also identifying the metal from the periodic table. Thank you for watching or listening, depending on what platform you're using. Probably watching.